So today we're going to talk about what happens if the bases don't match. All the other videos, the other two that I posted, both had to do with the bases matching, which remember is the big number. So today we're going to talk about what happens if the base doesn't match. And it's kind of simple, but some of the problems can get a little bit hard. So if we have something like 4 to the third times 5 to the third. So in this case, all right, my bases don't match, but my exponents do. Okay, so this step that we're doing works if your exponents match and your bases don't. So all this is, remember when we talked about if I had an exponent on the outside of the parentheses, how I had to go to everything inside? Well, we can kind of undo that process. So the way that would look is something like this. 4 to the third became the 4, 5 to the third became the 5, and the third power went on the outside of my parentheses. So now that I have this, all I have to do is simplify what's inside the parentheses. 4 times 5, which is 20. So this is 20 to the third. Okay, so right here, this became this. That's all I'm looking for. Remember, unless they say evaluate, we just want to simplify it. All right, so if we have another one, some of the ones in your packet start off looking something like this. Well, all we have to do here, these bases don't match, so we multiply them because it says 9 times 3. 9 times 3 is 27, and then I bring that exponent over. Okay, so this is the same thing as 27 to the 7th. What if I have a division problem? Works the same way. Neither of these can get combined together like we talked about before because their bases don't match, but we can pull those bases out and pull that exponent out because the exponents match. So this looks something like that. 8 over 6 to the 4th power. Now I can simplify everything inside these parentheses, and this right here, it doesn't divide evenly, so I'm not going to turn it into a decimal. I'm just going to simplify it into a simplified fraction. 2 goes into both of these. 8 divided by 2 is 4, 6 divided by 2 is 3, and then I still bring it to the 4th power. All right, so if you don't remember how to simplify a fraction, use your calculator. If you have one like this, it's the ABC button. And I know some of you have the other kind, but you have that fraction button on there. So you just simplify it, and then you leave it to the 4th power. All right, let me erase these so I have a little more room. All right, so let's do another one like that. If we have 10 squared over 5 squared, we're going to do the same thing. We're going to pull that power out. And then we're going to simplify inside. Now 10 over 5 simplifies all the way down to 2 because 10 divided by 5 is 2. So this is really just 2 squared. All right, so then we can also have something like this. Okay, so when I have something like this, remember if the negative is inside the parentheses, it means that the power gets applied to that negative also. But here, we have the same exponent, so this is just like negative 8 times negative 4, all raised to the 3rd power. Since those negatives stayed inside with it, we have a negative times a negative, which becomes a positive, and then we have 8 times 4, which is 32. Okay? The only reason this negative disappeared was because these were both negative. All right? So if I had something like this, the exponents match, so I can do the same thing. But because I had one negative and one positive, my answer is negative 32 to the 3rd power. Okay, so now my negative stayed there. So the negative only disappeared here because I had 2 negatives. All right, let's do one more. It's going to look a little bit like that top one there. so here I have a division problem and I have a power to a power. So we're going to start with that outside exponent and distribute it inside. So we have 5 to the 10th over 10 to the 10th. So again, my bases don't match, but my exponents do. Okay, 5/10 to the 10th. Now 5/10 reduces again to 1/2. So we have 1/2 to the 10th power. Okay? So then at some point in your packet, it's going to ask you to rewrite expressions using only 1 or 2 powers. All right? So they want you to rewrite it as either a quotient or a product using 2 powers. So if you have something that looks like this, we're just going to simplify it one step at a time. So we're going to start with this outside power and we're going to distribute it inside, okay? So here, remember a power to a power means I multiply. So this 3 to the 6th, I'm just going to bring down. I haven't done anything with it yet. And it's being multiplied by 9 to the 3rd to the 3rd. 3 times 3 is 9, so I have 9 to the 9th. Then here we have 3 to the 4th to the 3rd. So 4 times 3 is 12, so 3 to the 12th. Now here, this is not the distributive property because inside we have a multiplication sign. So we are not going to do any distributing, but we could rewrite this using just multiplication signs. Now I have 3 numbers being multiplied by each other, which we can do in any order, right? We can multiply these 2 together first or these 2 together first, whatever we want. So I'm going to find the 2 that have the same base and I'm going to combine those, okay? So again, when we have 2 numbers with the same base, just like yesterday's videos, we add together the exponents because it's a multiplication problem. So 3 to the 6th plus 12 times 9 to the 9th. 6 plus 12, so I just add those together, 3 to the 18th times 9 to the 9th. These do not have the same base, and they do not have the same exponent, so I'm done. Okay, but it said to do it as a multiplication problem or a division problem with 2 exponents, so we're good to go. All right? So let's do another one like that. So here we have 3 to the 4th times 6 to the 3rd over 3 to the 5th, all raised to the 4th power. So this exponent here is going to get distributed to everything inside, which remember when we distribute that exponent from the outside, it gets multiplied by the ones inside. So 4 times 4, so this is 3 to the 16th, 3 times 4, so this is 6 to the 12th, over 5 times 4 is 20, so 3 to the 20th. Okay, so there's step 1. Then I'm going to look and see, do I have any that have the same base or the same exponent that can be combined further? And I do. I have 2 here that have the same base. All right, so we're going to talk about negative exponents in the next part of the video, but right now, because if we did 16 minus 20, we'd get a negative. Right now, we're just going to look at it like this. Where do I have more 3's? Because remember, what I'm doing is canceling out, and this goes on, and this goes on. I'm canceling out however many 3's there are, right? 3 over 3 is 1, 3 over 3 is 1. Up top, I have 16 3's. On the bottom, I have 20 3's. So where do I have more? I have more on the bottom. And how many more do I have? I have 20 minus 16 is 4. So left on the bottom are 4 3's. This 6 didn't change at all, so it's going to stay up top. Okay? You know, it's a little bit confusing. Maybe when I get into the negative exponents, some of that will make a little more sense. And again, if you have questions, Mr. Wicklund put up like a question place where you can ask me specific questions if there's one I didn't cover. All right, so let's do one more like this. Well, here, let me do it up here. And then I'll get into the negative exponents. Okay, so here we have this exponent on the outside that we're going to distribute. All right, 4 to the 20th to the 3rd, so I do 20 times 3, which gives me 60. 8 times 3, which is 24. And 10 times 3, which is 30. All right, and then I look and see I have these two here have the same base. So what can I do with them? Well, I can simplify them. 60 minus 30 is 30. That means there are 30 more 4s up top. So I'm going to keep those 34s up top. This 3 didn't change at all, so I'm going to leave it right there. And that's my answer. Okay, so now let's talk about negative exponents. Negative exponents really just mean that the number is not happy where it is. If it's up top, it's not happy there. If it's on the bottom, it's not happy there. Okay, we're just talking top and bottom, like numerator and denominator. So if you have something like this, we're not talking about a negative base, we're talking about a negative exponent. This negative exponent tells me this number needs to move. So right now, it's on top, because remember, any number we can put over 1. If we don't see a fraction, then it's at the top because it's over 1. So to make it happy, I need to move it into the bottom. So this equals 1 over 3 to the 4th. Once I move it to the bottom, it becomes positive. That's it. That's all a negative exponent is telling me to do. Switch it to the denominator, or if it's already in the denominator, switch it to the numerator. So if I had something like this, 5 to the negative 3rd, this is simply 1 over 5 to the 3rd. Let's look at one where it's already in the denominator. So if we have 1 over 4 to the negative 8, this is 4 to the negative 8 over 1, but I don't have to write that, remember? So I'm just going to leave it just like that. Oh, I'm sorry, I forgot to get rid of my negative. So it's 4 to the 8. All right? Remember, when I move its location, I change it to a positive. So when I move this up top, 1 over 3 to the negative 4th is going to become 3 to the 4th. That's it. So let's look at one that has 1 in both spots. So if I have 3 to the negative 3 over 6 to the negative 2. This tells me neither of them are happy where they are, so we're going to switch them both. This needs to move to the bottom. This needs to move to the top. That's it. If these simplified further, like they have the same base or the same exponent, we could simplify them further. Okay, let's do this one. So I have 2 negative exponents here. That means both of these are not okay. I'm going to distribute this negative exponent here to both of these. So this becomes 2 to the negative 4 over 7 to the negative 4 times negative 18 to the negative 3. This is not happy up top. This is not happy in the bottom. So I'm going to switch them. 7 to the 4th over 2 to the 4th. Now those are good to go, but I have this guy to consider. So I'm going to bring him. He was unhappy. He's in the top, remember, he's over 1. I'm going to move him to the bottom. Okay. This we could consider simplifying too, but for right now I just want you to see what I'm doing with my negatives. All right. Let's do one more and then I'll do an evaluation one with you. This guy has to get distributed, so we're going to bring him to everything inside. Negative 2 times negative 3 is 6. Negative 3 times negative 3 is 9. Negative 1 times negative 3 is 3. And negative 2 times negative 3 is 6. Okay? So that got simplified quite a bit, and notice that it got rid of all my negative exponents. So nothing needs to switch places. So now I'm just going to simplify like normal. There's a couple different ways you could do it, but we're going to start off by looking at the 7s. Where do I have more 7s? I have 6 up top, 3 on the bottom. So that means I have 3 more on the top than I did the bottom, so they're going to stay on top. Where do I have more 4s? I have more on top. I have 3 more on top to be exact, because 9 minus 6 is 3. There's my final answer. Actually, that's not true. I can simplify this further because they have the same exponent. So this is 7 times 4 all to the 3rd power, and 7 times 4 is 28. Okay? So that's my final answer right there. All of this got simplified all the way down to that. All right, now let's do 1 or 2 with an evaluation, and then we'll be finished. So in this section, it tells you to evaluate. That means, again, we want to get it all the way down to a number answer, no exponents, nothing. We'll use a calculator. We're going to start by simplifying. If you wanted to type all this into a calculator, you can. It just gets really hard, and it depends what kind of calculator you have, how many sets of parentheses you need to keep things separated to make sure the calculator knows what order to do everything in. So I like to simplify it first. Because the rules for simplifying are pretty simple, we're just going to multiply all of these. So negative 4 times negative 3 is a positive 12. 6 times negative 3 is a negative 18. 3 times negative 3, so we have 6 to the negative 9. And negative 1 times negative 3, so we have a positive 3. So we can combine the top pieces by adding my exponents, because they have the same base and it's a multiplication problem. 12 plus negative 18 gives me, when I add 12 and negative 18, negative 6. Negative 9 plus 3, because I'm going to do the bottom part here, also gives me negative 6. So then I can pull that negative 6 away. Actually, no, let's do this first before we do that. Let's go ahead and switch them so the negatives are happy. All right, so we're going to put 6 to the 3rd over, 6 to the 6th over 3 to the 6th. Okay, this was negative, so I switched them and made them positive. Then I'm going to pull it out. And then I'm going to simplify. 6 over 3 equals 2 to the 6th. All right, 2 to the 6th, when I put it in my calculator, I find out that it equals 64. Okay, this is where I stop when I'm just simplifying or giving it to one exponent. This is where I stop when it tells me to evaluate. Let's do one more and then we will be good. So again, this is an evaluate one. I shouldn't have erased that part. Okay. This guy's negative, so he's unhappy. This guy's a 0. Whenever we have an exponent of 0, it equals 1, right? So we already know that that's just 1. And anything times 1 doesn't change. So really, we can ignore all of this. So 4 to the 3rd stays where it is. 4 to the negative 4th needs to move underneath to become positive. Now I'm just going to look at this. Where do I have more 4s? I have 3 4s up here, 4 4s down here. So I have 1 more 4 on the bottom than I did on the top. So it stays in the bottom. Anything else can get replaced with a 1. So it just becomes 1/4. Okay? You can make this 4 to the 1st power, but you don't need to. All right? If you have any other questions, or if I didn't cover something well enough, or I maybe was too confusing, I'm trying to talk fast so these videos aren't too long, please fill out that form that Mr. Wicklund put on there, or email me and I'll be happy to help. All right? Bye-bye.